Okay, we got a clean slate now. So, you know what?
What?
Let's put oh, it's not. There it goes. Oh, what's all that mess? That's okay. Oh, I started erasing earlier. So let's get rid of all this junk right here. Yeah, I want to keep these points right here. I thought I was going to start with a clean slate, but watch this. If it goes up like this, would we say it was going to happen at 90? The dotted line, right? It's undefined. All right, so this looks very familiar to the what? The tangent, right? Didn't we do the tangent the other day? And it had a dotted line? All right. What about this? Now, you see what's going to happen. It's going to go here, and it's going to follow that nice smooth curve all the way up, and it gets closer and closer and closer to 90 degrees, but it will never touch. All right? It's a pretty ugly smooth curve, but you get the idea. All right, so it goes up like this, and it gets really close to that 90 degrees, but it never touches. Now watch this. At 90 degrees, it's undefined, right? And why is the secant undefined at 90 degrees? I mean, the tangent's fine, right? Oh, sorry. Oh, right. Why did I think tangent? I'm thinking tangent. That's so weird. Okay, yeah, I'm thinking cosine. The cosine is 0, right? But the inverse of it, which is the secant, would be the inverse of 0, which would be undefined, right? It's null set. Okay. So there you go. It's 90 degrees. Where else is it going to be? At 270. Or 270 is the same spot as what? If I went that way, it's the same as negative 90, isn't it? So at negative 90, guess what's going to happen? It's going to be a dotted line. Now, if you just look at the graph, forget this thing right here. Okay? Just look at this. The cosine was 0, so what's the inverse going to be? It's going to be undefined, isn't it? Where else is it going to be undefined? Right here, right here. Do you see that? Everywhere it's 0 on this axis, it's going to be undefined for the secant. All right? It's 0 for the cosine, but it's going to be undefined for the secant because it's the inverse. Remember, finding the inverse. So really, everywhere on this dotted line, on these where it hits the 0, it's going to be a dotted line. What was the crazy fancy word we used? Asymptote. Okay, sounds weird to kind of put the P in there, but I guess that's how you say it. Now look at this. Those are our two asymptotes. What do you think? You think it just starts here and goes like this? Now, without even putting any points in an XY chart, what do you think it's going to do here? You think it's going to go down or what? It's going to go up and repeat the same exact thing. Okay, and you can put points in. You can put over here in the second, or actually, it would be over here in the fourth quadrant, wouldn't it? All these negative numbers, and you'd find out you're going to get exactly the same y values for those negative numbers this way. So, you know, it's going to. I'm just not even going to put the points in. Watch. Oh, that's pretty bad. Well, I do know it should hit right there, right? So that gives me some kind of reference. Let's see. It'll go about. Yeah, right. I'm drawing to the left. Oh, I sure did miss. It's supposed to hit right here, but you get the idea. All right? That's part of it. That's not the whole thing, though. Watch this. Where else is there going to be a dotted line? 270. At 270. All right? So we're going to come down like this. And watch. This one started at the top of the curve, and it went up to infinity, didn't it? So where do you think? If you go down here, that's exactly right. Now, if you wanted to, we're not going to, but you can do this on your own time if you don't believe me. Do a little XY chart thing, you know, fill in, you know, the cosine of 120, 135, 150, 180, and all those. Take the inverses of those, and I'll bet you anything that it looks like this. So it comes down like that. Okay, it'll come down like this, and it'll look something like that. That's one full rotation. What's the period of this? This is the secant. I should have written this right at the beginning. That's the secant. It's the inverse of the cosine. What's the period of it? Where does it start and stop? Or how many degrees does it take to start and stop? Well, if you start here at the beginning, that's negative 90, and it goes all the way to where? 270. How many degrees is it from negative 90 to 270? Yeah, because look, this is negative 90, isn't it? How many degrees to get to 270? 360 degrees. All right, so that's the period. The tangent was only 180, wasn't it? Because it just repeated the same pattern every 180 degrees. This repeats the same pattern every what? 360 degrees, right? Okay. Now, that's kind of junky looking right there. The reason I got this program, I'll tell you what, I'm going to put the I'm going to actually put it in there, and we'll see. So now I'm going to actually click on this, and it's going to show me what I should get, and there it is. All right. Now I was off a little. See, I was supposed to go through that point right there. Do you remember that? Okay, and I was way off, but they didn't mess it up. Okay, they got nice here, and you see it just repeats it. Every time you go to the bottom of the curve, it goes down. Every time at the top of the curve, it goes up. Every time you have zeros on the cosine, right? You got zeros here. What's that going to be on the secant or the inverse functions? It's going to be the asymptote. Make any sense? All right, that's what it looks like. Pretty crazy. Let's do this. Let's get rid of all my junk. Now it looks nice and pretty. And if you want, I mean, you can get rid of the cosine, but I like the cosine there. I wouldn't graph it straight like this. What I would do if I was asked to graph the secant, you may not have to put in the actual curve, but put in some main points for the cosine, because you know what they are off the top of your head, don't you? All right, you know what the cosine of 0 degrees is. You know what the cosine of 180, of 270, of 360. So that gives you an idea what it's going to look like, and that gives you an idea what your inverse functions are going to look like. Okay? So really, the curve of the cosine, I think, is very important to draw to the, to that right there. Okay? Does that make any sense at all?
Yeah.
What do you think the sine's going to do? Let's get rid of that. Get rid of that. But yeah, but just shift it. It's going to be the same thing. James said it right. It's going to be just like what we did, but on the sine curve. All right. Every time it humps up over the top, it's going to go up. Every time it's down the bottom, it's going to go down. So let's put the sine curve in there. All right. So there's your regular sine curve. Notice it goes through the origin, okay, from down below, and it goes up like this. It's basically the cosine, but it's just pushed over 90 degrees, isn't it? Shifted over, right? So that's our sine curve. Now, if I have my sine curve written, you could do the what's that called? What's the inverse of the sine? Cosecant. So I could graph y equals the cosecant of theta. Sometimes they use accents. That's fine. All right. So let's do that. What would it look like if I wanted to? Where would I put my asymptotes this time? Well, every time there's a 0, that's what I'm going to put down. I'm going to put an asymptote right there. So I'm going to put the asymptote right here. So the y-axis is actually a place where this cosecant's not going to ever touch. Oops. And where else? At 180, right? Yep. All right. Still with me?
Yeah.
You awake? All right. I know, it's right after lunch. It's a warm day. It's warm in here. But we're learning so much good math. You don't want to ruin it, do you? All right, here we go. Watch what we're going to do. If you're just going to sketch this. Now, this is what you're going to do on the homeworks, okay? Again, you don't have to draw the nice cosine here if you don't want to. You could just put some key points. You're like, oh, 0. So if it's 0 on the cosine, what is it on the cosecant? I'm sorry. This is sine. Sorry, I keep going back to cosine. Keep me straight, would you? All right, this is the sine. Okay, so 0 on the sine is going to be where it's undefined on the cosecant. So every time it's a 0 on the sine, I can just put the dots there, can't I? I don't really need to put the little wave there. I can just put the dots and say, oh, that's where 0 is on the sine. I can put my dotted lines, my asymptotes, and that's where it's going to be on the cosecant. Right? Look, halfway between the dotted lines, it comes up like this, doesn't it? So what do you think my graph's going to look like? It's going to go here, and it's going to go what? It's going to go up like this, and it's going to come here, and it's going to go up like that. You come down to the bottom, at 270 it's -1, and it's just going to go down like this. So it's really not all that hard to graph if you've already thought about it being the inverse of the sine, correct? James, what were you going to say?
No.
Just confirming what I said? Okay. All right, and if you wanted to keep on going, you could keep on going, couldn't you? You could swoop it up like this. You could take this one, put your asymptotes there, swoop it down. So if you're going to graph something, all right, what you want to do is you want to make sure that you have your asymptotes there. What am I checking for? Like on a quiz or a test, if I ask you to graph something like this, I'm looking that this point right there is where it's supposed to be, at 90 and 1. You with me? I'm looking to see if this point's where it's supposed to be. I'm looking to see where your asymptotes are, and they need to be in the right place. And then I just need to see the curve going up like this. Do I need every little point in here exactly right? No. I just need to see that little swipe up here, so you have that little parabola type of graph look. Make sense? So it doesn't have to be perfect, but there are key things I'm looking for. I'm looking for the asymptotes, looking for this, 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 and this point on there. And you go from there. We good with that? Okay.
Are you going to give us a graph?
Well, I'll give you things to graph. I mean, if you looked in last night's homework, you'll see, what you're supposed to do. I'll tell you what, I got about 30 seconds left. Let me just do this. Let me show you the inverse. Come on, there it is. Okay, there it is right there. Just like, now this is pretty ugly compared to what they did. All right, but it would be fine, right? You could still get credit for it, even if it looked as bad as mine did. All right, let's go to tangent and the inverse tangent, and then we'll be finished.